these are the notes for target 2 in the light and color unit. So the target is color by addition, and so what you need to be able to do is predict resultant colors. Resultant means what you get when you mix other colors. All right, so the result, when mixing lights, that's important, via the process of color by addition. One thing you'll want to have available to you is your formula sheet, depending on which trimester you have this class, which color I happen to copy them on, but you're looking for a color wheel, and it's not going to have all this writing on it. So you will want to grab that, maybe pause me until you can find it so you can put these helpful hints on there. One of the things you need to realize, okay, one of the most important things that we need to realize when we deal with color, the color that we perceive something as is simply the light that is being reflected off of it. So if you have on a red shirt, you only know that it is red because that shirt is absorbing every other color and reflecting red. It is not trapping it, because the only color we see is what is bounced off the object and comes back to our eyes. All right, so the color of light and object appears is based on the color it reflects. We only see what gets reflected. That is a huge, huge theme in this unit. Okay, we only see the color that gets reflected. Because what we should know by now in our science-y careers, this is the sun, we know that Roy G. Biv, okay, every color of the rainbow is coming down into Earth's atmosphere. So it's coming through a window right now into this room, for example. And so when we look out and we see a tree, all right, you know how fantastic these drawings are. So we see a tree, and this tree has green leaves. It's the summer, all right? So there's our green tree. The only reason that you can see that that is green right now is because that color is reflecting off. All right, so we know, and for right now, just go with this, and you'll understand why in a second. Red, blue, and green, we call these the primary colors of light, are shining on this tree. When that tree absorbs the red and the blue, the only thing available to bounce to our eyes is green. That's why we see it as green. In the fall, when let's say you've got a maple tree that's a nice red color, well, why is it red? Because now blue and green are trapped and red bounces off. The RO part of Roy G. Biv, the reds and the oranges bounce off. Okay, so depending on the pigments and dyes and all those things in objects, that determines what sticks in the object. What sticks in the object we don't see. What reflects off we do see. All right, that's a really important rule. So this absorbs red and blue, reflects green. Okay, so absorbs red and blue, reflects green. We will put this color wheel in our notes, okay, but again, you still should have it on your formula sheet as well. So I'm going to list off some colors you just want to copy down. We need red at the top. We need cyan at the bottom. Cyan is like a blue-green color, a teal color. We all know what yellow is. Yellow, green, go green, right? Oh, we got blue over here. None of that go blue stuff unless it's go Blue Jays. And then magenta. Alright, so we've got this color wheel. Squares. Put squares around red, blue, and green. Notice on your color wheel, red, blue, and green are already in squares. We're going to make a little legend. Square means it is a primary color of light. You've got to let go what you know to be true in art class now. Okay, you've got to let that go. What we are talking about is when you just have, let's say, spotlights that are overlapping. Or maybe, what would be probably a more relevant example, when you look at your cell phone screen, you see many, many shades of colors, right? Millions, thousands of shades of colors. There are only 3 colors of pixels on your cell phone screen though. Red, blue, and green. Red, blue, and green, when you overlap them, you can make every other shade of color. When we are just talking lights, not talking paint and crayons here, okay? We are just talking lights. So a computer screen, your Chromebook screen, you get all kinds of crazy colors and shades. There are only red, blue, and green pixels. Your smart TV at home, red, blue, and green pixels. I don't care if it's 4K. Still, red, blue, and green pixels, just many more of them, okay, lots more of them than in like a 1080p or something like that, a regular HD TV. Okay, so red, blue, and green are the primary colors of light. Put a circle around magenta, yellow, and cyan. These are secondary colors of light. So what you might want to do here is somewhere have the square for primary color, circle secondary. Next thing we do, take a dashed line and connect colors that are across from each other. This becomes possibly even more important in LT3, where we talk about color by subtraction. But these colors are complementary, not like a complement of, hey, you played really good in the basketball game last night. Okay, that's a L-I meant. These are 2 things that go together. So in my mind, you can't have peanut butter without the jelly. All right, so 2 things that go together. They are complementary colors. So we want to make sure that you have that on here also. We're going to worry about this pigment thing tomorrow, or whenever it is that we do LT3. Okay, but complementary, for now, just go with it. All right, so the main things to understand from this target are we see the color that gets reflected, like the green tree leaves. But then, how do we predict when you mix 2 colors, what is the resultant? So what do you end up with? So if you take a red and a blue, the resultant color is what is on the right side of the arrow, or what do you get? We can put an equal sign there, it doesn't matter. Red plus blue, you look on the color wheel, they are both primary. The secondary color they create is what lies between them. Okay, so red plus blue makes magenta. So if we went red plus green, 2 different primary colors. Red plus green makes the secondary color of yellow. Blue plus green makes blue plus green cyan. Now, if you're in class when we're doing this, you know that we are also working through the color by addition gizmo. Okay, the color by addition gizmo. It would be fantastic if you had enough motivation right now, if you were absent or whatever, if you could pull that up on your Chromebook, the color by addition one, and play with those spotlights. Overlap a red and a blue. Make sure you get magenta. Like, what if you made it more blue than red? You would see that you get a more purple color. If you have more red than blue, you get more of a maroon color. Go Scots. Maybe if it's red and green, okay, you can change it to more of a lime green look versus a yellow. Blue and green, you can make it more green and get like a really turquoisey look, or a more blue that's more of like a sea blue or something like that. All right, so hopefully you'll start to see that you can get all kinds of shades just with those 3 colors, with red, with blue, with green, because those are the primary colors of light. What you also will see is if you put all of these colors together, red plus blue plus green, and you overlap those, you get white. Okay, all of the colors combined creates white. Think about a white t-shirt. You've got all of the sunlight bouncing off of your t-shirt that appears as white. That's because red, blue, and green bounce to your eyes, and you have what are called cone cells in your eyes. Okay, they're microscopic, they're cells, and they detect red, blue, and green if you have normal color vision. So therefore, you perceive that shirt as white. If you look at a black t-shirt, that that shirt is black because no light is reflecting from it to your eyes. If you see somebody standing there in a black t-shirt, the only reason you can see that t-shirt is because light is being reflected from other parts of their body or the other parts of the room that they're standing in or wherever they're at. You might see some background, all right, something over their shoulder. Maybe their skin is reflecting some white, whatever, reflecting the colors. So the only reason you see that black t-shirt is because there's other colors bouncing off of objects around it. And that's kind of hard for us to grasp. So again, I encourage you before you take this target to go to the Color by Addition gizmo, play around with these color wheels and get comfortable with that, and make sure you've added those things to your formula sheet on the color wheel. Good luck.